Hey, good morning, everybody. Well, at least in this part of the world, and hope that everybody enjoyed that new introduction that we have. And want to thank our sponsors today. The ones that you see above our screen here are the ones that are making these coffee chats possible. So we want to give a very special thanks to them. And we also want to give a very special thanks to our guest today, which is Bonna Newman from TNO. So we have a celebrity in the house, yeah, and we're also going to allow Heinz to kick things off as he normally does. So Heinz, I'm going to let you start the session off. We've got Navi on screen already. Antonin, where are you? Don't forget to turn on your camera, okay? There we go. Heinz, I'll let you take it over.
Okay, many thanks for giving me the word, Brian. I'm Hans Ossenbrink. Today, after my retirement, majorly involved in organizing conferences and giving some insight into the PV field to all of you. Now, today's guest for our coffee chat is Dr. Bonna Newman. She's senior scientist and program manager of the crystalline silicon module technologies and mobility, PV and mobility at TNO in the Netherlands, but most of all, I think, known as a driver behind the technology which ends up on the Lightyear 1 car. And we will have today the opportunity to get a little bit an insight of how she sees the photovoltaic in vehicle world and a little bit about her current career. Now, I strongly recommend for any viewer to look back into her famous talk at the University of New South Wales and on the 9th of February 2020, which is exactly 2 years ago. And that leads me to my trigger question: what happened in this almost exactly 2 years? But I don't want to hear Corona. Bonna.
Well, thanks, Heinz, and thanks everyone for the chance to chat today. What's happened? Well, quite a bit has actually happened in solar mobility, as we now like to call the field. VIPVs ends up being very technical for many people outside of the PV world. Essentially, I think the biggest thing that's happened is that it's still here. I think 2 years ago, right as I was giving that presentation, Sono Motors was in the process of trying to raise 50 million euro in 50 days. They were successful doing it in a crowdsourced way. And I think that helped make people realize that this was something that people were like, this is a technology people were very interested in, and that there could be a potential market. And after that, now both Sono and Lightyear, the two main commercial players here, at least in Europe, have been able to continue to raise money, and they're still working towards actual vehicle production, which of course is a very capital intensive concept. In the meantime, they also have developed more and more pilot vehicles that are actually out on the road now and being tested. And so in addition to having having just existing, we actually now are starting to have vehicles on the road that we can actually look at measurements and see how they're performing, and get, instead of just doing modeling, we now have a much better idea of how these vehicles will actually perform and what the solar on board can actually promise and deliver. So you can look at some of the new results that Lightyear has been announcing about some of their racetrack tests of how many kilometers the vehicle can go on the sun. You also see Sono now expanding quite a bit more into other areas where there have been other players as well. So putting PV on trucks and trailers and other sorts of vehicle delivery systems. So, really, we've seen this huge explosion of the number of applications here, and where solar may be available and seen on the road very soon.
The racetrack testing you do in Zandvoort.
Well, no, so I'm not doing that. So
I mean,
yeah, it is. Some of it's happening in Zandvoort. I think also quite a bit is going in Italy. I think there's a racetrack in Italy, actually near, it's in a town called Aprilia, I think just south of Rome. They're doing quite a bit of testing there, but I don't know all the details because I don't work for Lightyear. We've done some projects with them, but yeah, we work on the technology that's actually on board. It's the same technology that's on board the Lightyear very similar cell and module technology that's on board the Sono motors. And also in some ways, very similar to the technology that's being used by some companies in the US as well.
Okay. Now it would be Nabi's turn.
Okay, Heinz. Okay, one of the things that I noticed, and maybe I'm not aware about everything that's going on, especially in research and development, what I noticed that most of, I would say, interested companies who are developing the VIPV, working on the VIPV, are new companies. They have nothing really to do directly with the automotive, the real automotive industries. Of course, there are some people who are coming from the automotive industry, but in your research and development and work, do you have any contact with these big car makers, traditional car makers, I will call them? And can you give us, I don't know, kind of your connection, your overview about your understanding on how the car automotive, the car industry is looking to that new concept of driving?
Yeah, well, so we do have contact with a number of the larger OEMs. I can say that a number of the larger OEMs, this conventional car industry, are quite interested in what's happening with these developments about solar mobility. They, of course, are also they're also the current OEMs are I don't know all the details because I'm not a market specialist when it comes to automotive, but what I've been hearing from people who are is that automotive is facing, these larger OEMs and conventional OEMs are facing some really big challenges these days with respect to both the supply chain problems and then the electrical vehicle transformation, and they're making some interesting decisions regarding those. I think combined with the electric vehicle question is that they're looking at the possibilities and the potential of onboard solar for these electric vehicles because it potentially does help to alleviate range anxiety. Now, there's no official number of what is the criteria for this, but the number that I have heard a few times in conversations is that they're looking for at least 20 kilometers of solar range per day on average. Annually. So, but of course, this is something that also they have to deal with, which is the fact, and that we as the solar mobility industry have to deal with, is that in the summertime, actually 20 kilometers is not that hard to get for most vehicles. But in the wintertime, that's quite challenging, particularly in some locations like where I am today, here in the Netherlands. So there's a number of issues that go into that about how you get to 20 kilometers a day. And that's, I think, if we reach this, let's say, magic threshold of 20 kilometers a day, in some ways it might be a little bit like when we reach this magic threshold of 20% efficiency modules in conventional PV, where, many things became possible. And I think we're heading that direction with solar mobility, but of course, at 20 kilometers a day for the new vehicles, the vehicles that I call solar electric vehicles that are designed for that, that's not too hard to achieve. But if you just put solar on an existing EV, that is not so easy to achieve yet, but it's coming very soon, I think.
Well, what I can see through that, what you said, and what I can, in my understanding, that is going to be an intermediate solution before we can go fully VIPV, fully solar.
Well, what do you mean by fully solar? What do you see as fully solar?
Powered only by solar.
Oh, you envision, well, you live in a very sunny place.
It should be in a sunny place, that's for sure. But also we can, during one of our coffee chats we had with Christophe Balif, a nice discussion regarding the efficiency of the cells, and which is the heart of the solution, I would say. And of course, that's dreaming as I am. Why not using the 3V cells? But this is not realistic. And Christopher, if I remember, he just tell me, Nabil, do you know exactly how much that it costs? Of course, it's extremely expensive. It's over $100 a watt peak, which make it impossible. However, maybe could you see maybe an intermediate solution, something that it's maybe higher cost than the classical what we have today currently in the market, okay, in order to increase the range and make it as the EV. When the EV was launched, maybe over EV was launched, was the first car in the world, indeed, by Porsche. That was in the 80s, you know, when Porsche launched the first EV, it was an electrical car. So, but let's talk about what's going on right now. So since the EVs were launched in the first program by Chrysler, if my memory is good, over 25 years ago, it was with the range of 100 kilometers per day run. Okay, so maybe we can see exactly a kind of combination between cost and the range and make it stepwise. What do you think?
Well, I mean, I think you're somewhat right, but the thing that has made, I mean, solar electric vehicles and the idea of putting solar on cars actually has been around even since the 50s. Apparently Ford, I think it was Ford, had a funky old electric car that they put an old, I mean, it looked like a classic kind of like Model T or something that they put solar on and took it to an expo in like the 50s. So basically around the time that solar cells were first being made in the lab, they made a solar vehicle, and it, you know, of course didn't power it barely at all, but there, you know, the idea is not new. And I think in some ways we're kind of past the point of the like higher cost. It will be higher cost. What we're putting on cars today is not going to cost 10 cents per watt peak. And definitely not in the range of like less than, you know, 80 cents per watt peak at the installation level, let's say the full system installation level. We're looking somewhere probably more in the range of $1 to $2 per watt peak right now for the technology that's being, you know, commercialized at this moment. But so it is more expensive. It's practically, you know, an order of magnitude more expensive than, or at least multiple factors more expensive than what the utility scale PV is. But I think the question is, you know, and I don't see the large OEMs supporting these really, really high efficiency devices at, you know, hundreds of dollars per watt peak. I think that's too far outside of their range. There may be some special cases where, you know, a company that sells luxury cars can potentially put something on that's a much higher efficiency. But potentially as we bring in, say, perovskites and tandems, if this could be a place that, say, perovskites and tandems, for example, that are at the high 20% efficiencies, even at a slightly higher cost point, could really see some better development and an application. But of course, we have some reliability issues we have to solve there and some manufacturing issues that go in there. So we're not quite there yet, but hopefully that is something that's coming, I think, from a technology perspective in, say, the next 5 years that we'll start to work on.
Antonin has his hand up.
Yeah, Antonin.
Yes.
Go ahead, Antonin.
So yes. Yes.
Maybe-
Sorry. Yeah, just a question about aesthetism, because when it's about car, I think the aesthetism start to be a very important point, and yeah, I think that's a big question for PV manufacturing. So starting maybe on the field, which is not a big question, then in buildings, it starts to be closer to the eye, and now on cars. Then what is your answer to how to keep high performance, low cost or acceptable cost, and then increase aestheticism?
Yeah, I mean, it's important for sure. I mean, I'm not that much of a car person, but I still, when I was buying my last car, I thought about how the car looked before we actually made the purchase. I thought, oh no, I like that one better. It looks better. So I think it's something that we do really, if we're really going to span this out, you know, for the general public, and really large portions of the market, you know, being able to do different things with the appearance of the cells is going to be important, the appearance of the integrated product. You know, there are actually quite a few technologies out there now that offer pretty good performance, pretty decent trade-off in performance for aesthetics. I mean, CSUM has some nice technologies. There's some companies in the Netherlands that have some pretty interesting technologies. So I don't actually see the aesthetic part as being as much of the challenge when solar mobility is ready for the broader market that cares a lot about the aesthetics. In the meantime, part of the reason that TNO has been working a lot with this, you know, back contact cell and module technology, and particularly the conductive foil that we use, is that it allows us a lot of options with like arrangement of cells. And so even at the point where we're not putting any sort of color on top or doing anything else, we can also play with the way that the integrated PV just feels to someone. And so there have been discussions in car circles of things feel like scales, because that seems fast or reptilian, and maybe we like that on our cars or something. I mean, you can imagine, we've been doing it for years, right? People put all kinds of strange decals on their cars, like feathers and lightning strikes and other things that suggest it's fast and powerful. You know, all of this is potentially also something you, as a graphic designer or a visual designer, that they can potentially work with, I think. But yeah, it's something that will have to evolve with it, but I do see there are solutions out there that can actually play a role. And I think people that value that aesthetic very highly will be happy to trade off a few kilometers for that aesthetic, most likely. But there's still market research to be done.
I guess from my point of view, is that if we're going to put the solar on the vehicles, and I've already decided at that point that that's the kind of car that I want people to know that that's what I'm doing. So if it does look different, I think that's probably what I'm looking for in many respects, is the difference of what this car would look like to a traditional car. And I guess, you know, when we really kind of look at where the market could potentially go, and correct me if I'm wrong, is probably in long range transportation. That's where there's more of a fear of range anxiety rather than just, we'll say, my trip to the grocery store and back. Because worst case scenario, if I don't make it, I can always walk back, I guess, or wait for it to charge a little bit. But I would think that the trucking industry would be probably where we probably need to focus, we'll say, for the larger companies that are not starting from scratch and building a vehicle that aesthetically does have the design built into it, like Lightyear and Sono. And probably maybe the other larger automotive companies will probably focus on the trucking industry. And that was where maybe we could see a potential advantage. And again, we don't have to worry about aesthetics too much at that point.
Yeah, I agree with you. When it comes to personal cars, I think the early adopters here are going to be a little bit, say, like the Tesla Roadster adopters, and then the first Tesla adopters that, you know, they were people that there's a bit of a status to having this newer technology, having the EV that's really the new EV. And so in the first few years, that will be where it is. But there is a question of how it, you know, I think aesthetically where it expands to. But when you bring up trucking, and, you know, I have to agree with you there as well, that I think, especially when it comes to energy transition, the trucking and that transportation industry is where we can actually really have potentially a much larger like carbon impact and the climate impact. And as a scientist that wants to do that's one of the areas that, you know, the cars are very sexy, and actually it's a great way to get PV in people's hands. But when it comes to that impact, you know, getting on the car or the trucks and the buses, that's where I want to go. I want to get us there. I want to get it on every truck and bus if we can. And there's a lot of challenges in that, doing that, because of the way that the PV would be handled and the environmental aspects of it, of like the vibrations and the temperatures and the just the loads around and the way that these trucks are handled, et cetera. So there's a lot of exciting work to do there as well.
Bonna, you seem to be very, very much enthusiastic and still absolutely on the right track. There is a number of messages in the chat, which I find quite good. So basically around the glass cover. So one is on how much difference color can make when the solar cells themselves are colored, and the other is already, it seems to be a startup from Poland regarding colored front glass PV technologies with transparent glass with quantum dots. So obviously you're triggering also the inspiration by many others around the world working on PV. It's if I understand you right, the vehicle integrated PV or PV on cars, let's call it like this, or PV mobility is something not only sexy, but it seems to trigger a lot of ideas, because what you combine is the sense of independence, combined with the independence which gives you a car, or what you have shown on a video once. I think it was the video actually in Sydney, that you see this long roads and the sun behind, and it gives you this kind of freedom. And so it's much more than just imagining a PV plant which is sitting around somewhere. So, and I think it's a very good driver for this enthusiasm required to drive PV as such forward. So not only now as a direct application, but it seems to stimulate a lot of people.
Yeah, I agree with you there. I think, well, I grew up in America, and you know, the second I turned 16, I went out and got my driver's license, because in America, the private personal vehicle is your ticket to freedom from everything, right? Because you have to get around in the US, by parents especially. And so, yeah, I mean, I think I don't know how prevalent that same idea is for actually the generation of today, to be honest, because there's many people that are growing up today choosing not to necessarily have a personal vehicle and look at different ways of getting around. But there is definitely in your transportation, the transportation is how you get everywhere. And if you want to go somewhere and you want to go independently, you have a lot of different options for that. It doesn't mean that you have to have a private car to do so. But the other piece about that is that in your transportation choices, you get to make very independent and specific choices for yourself, your personal choices about how you're going to do that. And I think as we look for the future and we think about the energy transition and wanting to have as little impact from a personal perspective on the environment as we can, and helping to make the environment or the earth a place that all our future generations can be, our personal transportation choices are one of our biggest places where we can make these choices to have to be as low impact as possible. And solar mobility allows that to happen. If it's on your transportation of your goods that are showing up at your grocery store, or how those groceries get to you maybe in your apartment because you don't want to go out and you want them delivered, or whether or not you're taking a car to drive cross country. You know, on all of these different perspectives, you still get to make transportation choices. And this is a way that in some ways you can democratize the energy transition, as I see it, rather than being reliant on some company to put a bunch of solar panels in a field and connect them to the grid with a big fat cable. And then you can buy that, at least according to a contract, you're buying solar electricity.
It has no soul.
Exactly, yeah. And so I think it inspires people that way. It inspires me that way. So yeah,
this is.
I have just one comment coming here from Mr. Peter Pauli regarding a very interesting observation. He says that if we park the car in Doha, for instance, and we leave it for the full day, we're gonna load the batteries, but that's power in the battery will be enough to cool down the car. So would it not be more interesting to think, and this is also the point that I want to bring to the discussion, is to use the parking lot with the solar and then charge the cars, the EV cars, from that directly from the sun, rather than using today fossil fuel and say that it's clean, because it's not clean. that power comes from different sources of energy, starting from coal. So it's and doing so, can we, for instance, rank or call these EVs as VIPV because they will be charged by the solar?
Oh, are you saying to put in stationary solar in the parking lot?
Yeah.
Or you? Oh, yeah,
Yeah.
definitely. I mean, I don't think that onboard PV is something that should replace necessarily stationary PV to help charge EVs. I mean, it should definitely. That's a huge part of the equation. Even if we covered all these vehicle services with PV, and at the efficiencies we're looking at now, and kind of even forward projecting, you're still only looking at being able to probably produce somewhere in the range of at best about 60% of the added electricity demand from EVs on the grid by 2030, globally speaking. But you still need that other 40%, unless we're going to stop driving so much or stop moving so much, which probably is not what we're going to be doing. So you still have this 40% you have to fill, and that needs to be sustainable as well. So definitely we need stationary PV to be part of it as well. There's no way around that.
Mm. Would you see a market? What I'm sometimes thinking, there are still problems if we would say, okay, you have a carport PV, for example. Apart from the standardization issue, how to charge your EV with DC, that would be a real challenge that we get at least some standards into it. I'm always dreaming of that these carports are actually marketed by the car companies. So you would have your Tesla and the fitting Tesla carport, even in its design, to exactly this model, or the Mercedes or whatsoever. And I think one needs a little bit this marketing point of view, because car is such an emotional affair still. And I don't think that anybody who would be initially able to finance an Lightyear 1 is one of those who really desperately wants to save the climate by having a vehicle integrated PV. So it's more or less make yourself visible with solar. And therefore I see also this marketing possibility that you show that your electric car is not only electric, but it's solar electric. And in this direction, also a carport would perfectly fit. And it's always, we're getting in each of these chats, we're coming to one point always. So how much do you get by integration? How much do you get by just being close to the car? Or even, I think there was this remark on larger supermarket parking stores, which are covered by PV, and you get it free, or you get a discount, or whatever rebate on your client card if you charge by solar. So there are many, many of these possibilities. But still, I think the vehicle integrated PV is the most igniting one.
Yeah, I mean, I agree with you 100% that there's these other types of strategies that will come into play. I saw a question popping up just now about, say, like or like potentially the future of roads having covers that are covered in solar as well to allow charging. But again, if you're not near this, like, then you're dependent on infrastructure in any of these situations, or having a carport. I mean, I live in an apartment building and can't have a carport. So, there's quite a few people out there that still want to make these sort of decisions in the long term, but don't necessarily want to depend on the infrastructure being around. So those infrastructure aspects, that's actually something I work on quite a bit as well, is infrastructure integrated PV. And I think it plays a really large role in what we're looking at as the future. But I definitely see there still being a market for the solar mobility next to that, and actually having your own onboard systems for different situations. And you know what? If the best that would be is that actually our whole grid goes completely sustainable. It's all wind and solar that's coming on. And you know what? If we can get there fast, maybe we don't even need the onboard PV, to be honest, because we hit our sustainability goals. But until that actually happens and our governments make big decisions and corporations make big decisions to like get there tomorrow, we can all choose how we drive and where we get our power from.
Absolutely. Antonin, I think you're
for the
Antonin, you have your robot voice on.
Yeah. I don't know if I understood the robot. I'm sorry. Did anyone else catch it? You
No,
could translate
no.
from robot to. Sorry, Anderson.
Well, we're at the point anyways where we need to kind of wrap things up. We've hit our 30-minute mark, and things go pretty quickly when we have a great speaker with us today. And Bonna, you were great, and we certainly appreciate you taking the time out of your day to talk with us on Coffee Chat. And we do have another session coming up in a couple of weeks, which we'll be announcing soon. I think you would probably want to announce that, Antonin, but I don't know if you are able with your voice right now. But we do have Kiichi Komoto, one of your colleagues, Bonna, coming on soon. He's in IEA Task Force 17, I think it is for transportation, e-mobility, et cetera. So we're looking forward to that. We'll send out the exact day and time very soon. But otherwise, I just want to thank everybody for joining us today and being part of these informal discussions. And thanks very much to our audience as well. This is fun. I think we learn a lot from it, and I think we have a long way to go. And I think we're going to hit a lot of these targets in the very near future. So Heinz, I don't know if you had anything else that you wanted to say, but other than that, I'm done for now.
Thank you, Bonna. It was, as usual, great to listen to you, and in particular for your enthusiasm, which I think inspires everybody listening to our Coffee Chat.
Thanks, Heinz, and yours as well for supporting everything in the last few years as well, and everyone here. So looking forward to future conversations.
Definitely. Well, take care, everybody, and we'll look forward to staying in contact. See you soon. Bye-bye now.